Every single weld on a boiler, a nuclear reactor, or a high-pressure pipeline has to be proven safe before anyone strikes an arc. But how do engineers guarantee that? The answer is 3 letters, ASME Section IX. I'm going to break down exactly what it is, why it matters, and what you need to know. ASME, the American Society of Mechanical Engineers, publishes one of the most important engineering standards in the world, the Boiler and Pressure Vessel Code, or BPVC. Think of it as the rulebook for keeping high-pressure equipment from failing catastrophically. This code is divided into multiple sections. Section 1 covers power boilers. Section 8 covers pressure vessels. But before any of that equipment can be welded, you need to follow Section 9 welding, brazing, and fusing qualifications. Section 9 doesn't tell you how to design equipment. It tells you how to prove that your welding process and your welders are capable of producing safe, high-quality welds. At the heart of Section 9 are 3 critical documents. Master these and you've mastered Section 9. The WPS is the recipe. It's a written document that tells the welder exactly how to make a weld, the welding process, the base metal, the filler metal, preheat temperature, current settings, and more. Think of it as an instruction manual that must be followed every time. A WPS is only valid if it's been qualified, and that's where the next document comes in. The PQR is the proof. When you first develop a welding procedure, you must weld a test coupon, a sample piece, and physically test it. Bend it. Pull it apart in a tensile machine. Examine it under the microscope. If it passes, you document everything in the PQR. The PQR supports the WPS. You can't have a qualified WPS without a completed, passing PQR behind it. Even if your procedure is perfect, it means nothing if the welder can't execute it. The WPQ, or Welder Performance Qualification, proves that an individual welder has the skill to produce an acceptable weld using a qualified WPS. A welder qualifies by welding a test coupon. The coupon is then tested either by bending it or X-raying it, and if it passes, the welder is qualified. Here's where Section 9 gets technical, but stick with me, because this is where inspectors and engineers really earn their keep. Section 9 classifies welding variables into 3 categories. Essential variables: these are changes so significant that if you change them, your WPS is no longer qualified. You must re-qualify. Examples include changing the base metal P number group, or switching from one welding process to another. Non-essential variables: these can be changed and documented in an updated WPS without re-qualifying. Things like changing joint geometry or cleaning methods. Supplementary essential variables: these only become essential when notch toughness testing like impact testing is required by the referencing code. To keep things practical, Section 9 groups similar materials together using numbers. P numbers group base metals by similar composition and mechanical properties. P1 is carbon steel. P8 is austenitic stainless steel. If you qualify a weld on P1 carbon steel, that qualification covers a whole range of P1 materials, not just one specific grade. F numbers group filler metals. This means qualifying with one electrode may cover several similar electrodes. A numbers classify the chemical composition of the weld metal deposit itself. These groupings are incredibly powerful. They save manufacturers from having to run a new qualification test for every single material combination. The position you weld in matters a lot. Gravity affects how the molten weld pool behaves, so a welder qualified in the flat position is not automatically qualified to weld overhead or vertical. Section 9 defines standard test positions: 1G flat, 2G horizontal, 3G vertical, 4G overhead, and the famous 6G position for pipe. The 6G test is considered the most comprehensive. A welder who passes it is qualified for virtually all positions. Let's put it all together. Here's how the qualification process works in practice. Step 1. The manufacturer or contractor develops a draft WPS listing all the welding parameters they plan to use. Step 2. A test weld is made following the draft WPS. This weld is the qualification coupon. Step 3. The coupon is examined and tested: bend tests, tensile tests, sometimes impact tests, a radiographic examination. Step 4. If the tests pass, the results are recorded in the PQR, which is then used to support and certify the WPS. Step 5. Individual welders are then tested to that qualified WPS, producing their own WPQ records. Only then, with all three documents complete, can production welding legally begin on ASME code equipment. Section 9 applies anywhere ASME codes are enforced. That includes pressure vessels, boilers, nuclear power plants, petrochemical refineries, pharmaceutical manufacturing, and more. If you are a welding engineer, you write and qualify the WPS. If you are a QC inspector or CWI, you verify that the documentation is in order and the welds match the WPS. If you are a welder, you work within qualified procedures and maintain your WPQ records current. ASME Section IX is the foundation of safe, qualified welding in virtually every high-stakes industry. Master the WPS, PQR, and WPQ. Understand your essential variables. Know your P numbers and F numbers. And always keep your documentation tight. If you found this video helpful, like and subscribe. We'll be doing deep dives into each of these documents, step-by-step walkthroughs of writing a real WPS, and how to read and interpret a PQR. Drop your questions in the comments below. I read every single one. Until next time, weld safe, weld smart.